Good morning, students. So in the last lecture we have discussed different types of shallow foundations like strip footing, then combined footing, isolated footing, etc. So in today's class we can study about the design of rectangular footing. Okay. So the two types of combined footing are rectangular footing and trapezoidal footing, and the design of these two types of footings are there in your syllabus. So first, design of rectangular footing. Okay. So for that, consider this figure. So this is a rectangular footing, and here the load on the first column or the exterior column is Q1, and the load on the interior column is Q2. Okay, and Q is the total load. That is, Q is equal to Q1 plus Q2. Okay, and this is the plan. And in the plan also, this is the first column A, second column B, and we can look through the distance marked. That is, x bar is the distance between first column and that is center of the first column and the total load. Okay, x bar. So x bar is the distance between Q1 and Q. Okay, so it is also marked here. So x bar is the distance between first column and the center of gravity. Okay, and then here x1 and x2. x1 means x1 is the distance from the left hand edge to the center of first footing, x1, and x2 is the distance between two columns, that is A and B, that is x2. x2 is the distance between centers of two columns, that is x2. Okay, so x bar is the distance between center of first column and center of gravity, and here it is x1 bar. x1 bar is the distance from left hand edge to the center of gravity, x1 bar. Okay, so in this figure it is clear that x1 bar is equal to x1 plus x bar. Okay, so these distance values you should by heart. That is the notation. That is, x bar is the distance between center of first column and center of gravity. Then x1 is the distance from left hand edge to the first column, and x2 is the distance between centers of two columns, and x1 bar is the distance from left hand edge to the center of gravity. Okay, so you should clear about these notations. And L is the length of footing, B is the width of footing. Okay, so this is the step for designing the rectangular footing. So you should follow the design by these steps. That is, first step, you should take the moment at the point A, moment towards the first column. Okay, so equating sigma MA is equal to 0. So we have to take the moment at this point. So what are the forces? That is Q into this distance x bar. That is, we are taking moment at A, that is center of first column. Okay, that is Q into this distance x bar is equal to, then Q1 is acting through this line, so we cannot take this one. So for one parameter is Q into x bar. Q into x bar is equal to Q2 into, that is distance from Q2 and this first column, that is distance between these two columns are x2. So Q2 into x2. So what is x bar? Q2 into x1 by Q. So by taking moment at A, we will get x bar. So x bar is the distance from first column, center of first column to center of gravity. Okay, so we obtained x bar. And in the next step, we have to calculate x1 bar. So x1 bar, if we obtain the value of x bar is equal to x1 plus x bar. So x1 bar is equal to x1 plus x bar. Okay, that is the second step. And the third step is, that is, we have discussed in the last class, that is, for rectangular footing, the centroid or the center of gravity is at the center of the rectangle. So L by 2. So that for at a distance L by 2, the centroid will be acting. That is, x1 bar is equal to L by 2 in the case of rectangular footing. Okay, but for trapezoidal footing, this x1 bar is less than L by 2. That we have discussed in the last class. Okay, so required length L required will be equal to 2 times x1 bar. Okay, so L required is equal to 2 times x1 bar, because x1 bar is here. So since it is rectangular footing, it is acting correct at the center, so length will be is equal to 2 times x1 bar. So that is the third step. We have to calculate required length. L required is equal to 2 into x1 bar. The next step is from the previous step we obtained L required, that is length. So area is equal to when we obtain this length, we can calculate width by dividing area by length. So we have to calculate area, first area. So area required is equal to total load Q divided by QNA, ultimate bearing capacity QNA. So from this area we can calculate width B. Okay, so we have obtained length and width. So that is the design. So the aim of the design of a rectangular footing is we have to calculate what is the length and what is the width. So we have obtained length from this equation and width B from this equation. So our design is over. And the next step we have to draw pressure distribution diagram, and last step draw shear force diagram, bending moment diagram. But in this geotechnical stream, this step is not needed. You are studying this shear force diagram and bending moment diagram in your SA1, SA2 extra. So when the steps are asked for exam, you should write these steps. But for solving problem, up to this is required, I think. And you can also draw pressure distribution diagram, and this last step is not needed in this problem. Okay. So this is the procedure. So based on this step, we can do one problem. Design a rectangular combined footing for the following data: exterior column load 700 kilonewton, interior column load 800 kilonewton, and center to center distance 4 meter. So when you get a question like this, first draw the rough sketch. There is exterior column and the load on exterior column 700, interior column 800, and distance between that center to center distance is given as 4 meter. Okay, and maximum projection allowed along length direction is 0.3 meter from the edge of column. That is, here this distance is 0.3. Okay, that is x1 is equal to this okay, that is x1 x1 will be equal to this projection and half of this length. Okay, that is here the maximum projection allowed along length direction is 0.3, that is this small projection is 0.3, that is given in the question. So you should mark all these dimensions here and also draw the plan. So first step, take moment at A. Okay, that is q into x bar is equal to q2 into x2. So q2 is equal to 800 into x2 എന്ന് പറയുന്നത് center to center distance, so x2 4 meter divided by q എന്ന് പറയുന്നത് sum of q1 and q2, that is 700 plus 800. Okay, that is x bar is equal to 2.13 meter. And next step, calculate x1 bar. So x1 bar is equal to x1 plus x bar. And what is x1? What is x1? x1 means it is the distance from left hand edge to the center of first column. Okay, so the column dimension is given here, that is 0.4 by 0.4, that is this is 0.4, so half of this 0.2. So this small half of this column is 0.2, so 0.2 plus this projection 0.3, that is 0.2 plus 0.3 is x1, that is distance from left hand edge to center of first column, that is x1 bar, that is that is x1. So x1 is equal to 0.2. 0.2 is the projection distance plus half of the column width, that is 0.2 plus half of the column width 0.2, 0.2 plus this projection 0.3, that is 0.5 is x1. Okay, so x1 bar is equal to x1 plus x bar, that is x1 x bar is given obtained as 2.13. 2.13 plus 0.5, that is 2.633 is x1 bar. And next step, calculate L required. So L required is equal to 2 times x1 bar in the case of rectangular footing. So 2 times 2.633, that is 5.26 meter, approximately as 5.3 meter is required length. Okay, and when we are calculating the required length, we have to check whether the required length is greater than minimum length. Okay, so here minimum length means this is the minimum length, that is without any projection and all. So minimum length will be equal to this center to center distance 4 plus this half plus this half, that is without any projection, this is the minimum length value. So it will be equal to 4 plus this small half of the column plus half of the column, that is 4 plus 0.2 plus 0.2, that is 4 plus 0.4, that is 4.4 is the minimum length. So this required length is greater than L minimum, so the calculated required length is okay. So design is okay. So we have obtained the required length as 5.3, and also we have checked the required length, whether the required length is greater than minimum length. Okay, so hence our required length is correct. And the next step, we have to calculate area. So area is equal to total load Q by QNA, that is total load Q means Q1 plus Q2, that is 700 plus 800, divided by QNA is given as 150. So 1500 by 150, that is 10 meter square is area. So B we can calculate by dividing area by length. So 10 by 5.3, 1.89, approximate to 1.9 meter is the B. So this is the dimension. We have obtained length as 5.3 meter and width as 1.9 meter. So this is the design. Okay. So provide a rectangular combined footing with a size 5.3 meter by 1.9 meter, and the providing area is we can calculate area by multiplying length and width, that is 5.3 into 1.9, that is 10.07. So the pressure gradient at foundation line, that is load by area. So this is the total load 1500 by provided area is 10.07. So this is the pressure gradient, that is 148.96 meters. So this is the pressure distribution diagram, that is the final step. Okay, so the pressure gradient at the land, that is 148, which is acting upward direction in order to resist the load 700 and 800 kilonewton. So this is the rough sketch. Okay. So this is the design of rectangular footing. It's very simple. First you calculate x bar by taking moment at A. So we have obtained x bar. In the second step, calculate x1 bar. x1 bar is equal to x1 plus x bar. Then required length is 2 times x1 bar. And check whether the required length is greater than minimum length. Then our design is okay. Then calculate area. Okay. So from this area we can calculate width. So this is the required dimension of the rectangular combined footing, and we can also draw the pressure distribution diagram like this. Okay, so I think it's clear. If you have any doubt, please contact. It's very simple. Usually in university exam it will be asked for 10 marks. Okay, so in the next video I will put design of trapezoidal footing. Thank you.